Hello, welcome to this video about statistics with RKWard and the package rkTeaching. In this video, we're going to talk about linear regression models. That is how to fit a regression line to a data set and how to use that model in order to predict. Well, first of all, we're going to open the booklet for practices, and we're going to go to practice number 4. Exercise 1. Well, in exercise 1, I have two variables x and y, and we want to study first if there is a linear relation between x and y. So we're going to create these two variables in a new data set. Let's go to RKWard and create a new data set. I'm going to give a name to this data set, for instance, exercise 1 data. We're going to define the variables, the first variable x in the first column, name x. This variable is numeric, and the second column for variable y. And here just type the data 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And for y, 2, 5, 8, 11, 14, 17, 20, 23, 26, and 29. Well, in part B, it asks for the scatter plot. Well, remember that the scatter plot is a chart that is going to represent every individual in the sample as a point in a plane, in a Cartesian plane. And this chart is very important in regression, in a regression study, because it's going to give us the first clue about the type of relation between the variables. So let's see how to get the scatter plot with RKWard. All you have to do is follow these steps. Go to the menu Teaching, Charts, and Scatterplot. Let's go to the menu Teaching, Charts, and Scatterplot. In this dialog, all you have to do is select the variable that you want to represent in the y-axis, the y variable, and the variable that you want to represent in the x-axis, the x variable. Well, usually, the dependent variable is represented in the y-axis, and the independent variable is represented in the x-axis. But in this case, I don't know which variable is the dependent or the independent, because I don't know what is x and y. So we're assuming that y is the dependent variable and x is the independent one. Okay? And that's all. Submit. Don't worry about this message. That is just a warning about the package that has been loaded in order to plot the scatter plot, and the scatter plot appears just above. Here you have. Well, this is the scatter plot, and obviously in this case it's clear that there is a linear relation because all the lines, all the points are along the same line. Well, this data is fake, obviously, because in real life it's very difficult to get a perfect relation like this. Well, now that we know that the relation between x and y is linear, we are going to compute the regression line in part C. Okay? In order to compute that regression model, a linear regression model in RKWard, you have to go to the menu Teaching, Regression, and Linear Regression. So let's go to Teaching, Regression, and Linear Regression. In this dialog, you have to select the dependent variable in the model. We are assuming that y is a dependent variable. And the independent variables, here you can select more than one, but in this case, we're going to select only x because we have only two variables. And that's all. Submit. And here we get a summary with the regression line of y on x. And this is the linear regression model of y on x. Okay. The first thing that we get is the model equation, that is y equals to 2 plus 3x. Okay, this is the equation of the line that fits better the cloud of points in the scatter plot. And here you have a summary with the main coefficients of the model. Well, this model is a line, and it contains only two parameters that are the first term, that is the intercept that appears here, and the slope, that is the value that multiplies the independent variable, and this value appears here. And also we get the standard errors of the estimators. And just below it appears the R square coefficient of determination, and as you can see is 1, and that means that the fit of the model to the cloud of points is perfect. That is, there is no errors, there is no residuals. We can see that if we plot the regression line on the scatter plot. For that, again, all you have to do is run again the previous dialog. And here, if you want to plot a fitted model, go to the fitted line tab and select the type of model that you want to plot, in this case linear, and that's it. Submit, and here you have, as you can see, the line fits perfectly the cloud of points. Okay, and the equation of this line is the previous equation, is y equals 2 plus 3x. Okay, now we are going to compute the other line. Remember that you always have two lines. In one line y is the dependent variable and x the independent. In the other line, x is play the roles of dependent variable and y the independent one. So now we are going to compute the other line, the regression line of x and y. All you have to do is repeat the same steps: teaching, regression, linear regression, and select now x as the dependent variable and y as the independent one. Submit, and here we get the equation of this other line, the regression line of x and y. Well, this line is exactly the same than the previous line, okay, because if you in this equation you solve for x, you get exactly the same. This is the equation of the same line. Well, typically the two lines are going to be different, and there is only one case when the two lines are going to be the same, and this is this case when the fit of the lines are perfect. As you can see, no, the model fits perfectly, and only in this case the two lines are going to be the same. But this case is very rare in real life, so most of the times the equation of the two lines are going to be different. Okay. And the last question is, how are the residuals? Well, the residuals are the distance from the points to the line, and since the line passes through all the points, the residuals are all 0, or what is the same, the fit is perfect. Okay, and that's the reason why the coefficient of determination is 1. Okay, let's move on to exercise 2. That is more interesting because now we're going to manage real data. In exercise 2, I want to study if there is a relation between the number of hours that students study daily in a course and the failed subject and at the end of the course. Okay. Well, for this exercise, we are not going to type the dataset. We are going to load this dataset from the rkTeaching package. Remember that for that, all you have to do is go to workspace, other environments, and here you have all the packages. Look for the rkTeaching package here, and here it contains all the datasets, and the dataset in this case is study hours field subject. This is the name for the dataset. We're going to make a copy to our workspace, and now we can open this dataset. And this dataset contains two variables. The first one is study hours, daily hours of study, and the second one failed subjects at the end of the course. Okay. Well, the second question is construct the two-dimensional frequency table. Okay. In order to get the frequency table, we're going to go to teaching, frequency distribution, and two-dimensional frequency table. In this dialog, we're going to select which variable do you want to tabulate in rows. It doesn't matter, but let's say that study hours. And which variable do you want to tabulate in columns, failed subjects. Okay, I'm going to submit, and as you can see, I get a pretty long table, and the reason is because the number of hours in study hours is very different. Okay, so in this case, I think in order to summarize, we're going to group this data into intervals. For that, just run again. Here, go to row classes and select group rows into class intervals. We're going to use the default method for determine the number of intervals, and that's submit. And here we have, this is the two-dimensional frequency table, grouping hours into intervals of half an hour. Okay, and here for subjects. Let's go to part C. In this part, I want to fit the regression line of failed subjects on study hours, and we're going to plot it. Before computing the line, we're going to plot it. We're going to plot the scatter plot because it's a good idea to plot this plot always before starting a regression study. So go to teaching charts, Scatterplot, and we're going to select the variable failed subjects as the dependent variable in the y-axis, and study hours as the independent one. Submit, and here we get, this is the scatter plot. Well, now obviously the points, the dots are not on the same line. This is because this is a real study, but anyway, there is a clear tendency that is more or less linear and is inverse. That means that when you increase the number of study hours, the failed subjects is decreasing. Obviously this is common sense. If you study more, you're going to fail less. Well, so that means that it's a good idea to fit a linear model in this case, since the tendency is linear. So we're going to fit the regression line, and for that, let's go to teaching regression, linear regression. And in this dialog, all you have to do is select the dependent variable that is going to be failed subjects and the independent variable study hours, and that's all. Submit, and here you get the equation for this model. Failed subjects equals to 4.84 minus 1.23 study hours. As you can see here, the slope is negative because the relation between failed subjects and study hours is inverse. Yeah. It's very important to interpret the slope of the regression line because this parameter is the most important parameter in a relation, because it's going to tell us how is increasing the dependent variable with respect to the independent one. In this particular case, the interpretation is that for each study hours more that you study a day, you're going to fail 1.23 subjects less at the end of the course. Remember that the interpretation of the slope is how much increases or decreases the dependent variable for every unit that you increase the independent one. Well, let's move on to part D. That is is exactly the interpretation of the slope, because it asks what is the regression coefficient, that is the slope of the line, and interpret it. In part E, it asks for if the relation is stronger or weaker than in the previous exercise, and for that we need to go to the model goodness of fit, and that is have a look to the coefficient of determination, R squared, that in this case is 0.81. Remember that the coefficient of determination is always between 0 and 1. The closer to 1, the better the model, the better the fit. In this case, it's close to 1, so I can say that this is a good model, a pretty good model. The model fits quite well the cloud of points, but obviously the fit is worse than in the previous case, because in exercise 1 the fit was perfect. We're going to plot, we forgot to plot the line in the scatter plot, but we can plot it now. All you have to do is run again, go to the tab fitted line and select linear, and we get the fit of the line to the cloud of point. As you can see now, the fit is not perfect, but it fits quite well, no? The cloud of points. For that reason, I get a coefficient of determination close to 1, 0.81. Another way of interpreting the coefficient of determination is if you multiply this by 100 as a percentage. So that is that, and this is 81.5% approximately. So that means that this line, this model, explains approximately 81.5% of the variability of the dependent variable, of the variability of failed subjects. Well, now in part, if F, it asks for compute the linear coefficient of determination. Well, it's exactly what I just did. The coefficient of determination appears here, and what percentage of the variability of the failed subject is explained by the linear model is 81.5% approximately. Okay. In part G, it asks for use the linear model to predict the expected number of failed subjects for a student that study 3 hours a day. Okay, now that we have the model, that this model is a good model because the coefficient of determination is closer to 1, the sample size is not too small. We're going to use this model in order to predict, and this is a common practice because the main purpose of regression models is to predict the dependent variable for a particular value of the independent one. But before predicting, we need to save the model. Whenever I want to predict in RKWard, first we need to save the model, and for that we're going to run again the procedure for constructing the model. And all you have to do in order to save the model here is just click this save model and give a name to the model. I'm going to give a name to this model, that is regression line fail subjects on study hours. Okay, and then submit. After saving the model, if you go to workspace, you will see that in your workspace appears a new object like this, that is our regression model. This is the regression line that I've just saved, this one. And now we can use this model in order to predict. If I want to predict the failed subjects for students that study 3 hours a day, go to teaching, and then regression, and here predictions. In this dialog, we are going to select the model that you want to use in order to predict here. That is the regression line of failed subjects on the study hours. And here in prediction 4, all you have to do is write the values of the independent variable that you want to use for the prediction. You can write more than one, separated by commas, but in this case, it's for 3 hours. And then submit. And here you're gonna get what's the prediction with this with this line. What's the prediction for 3? Well, in fact, all I do is replace in this line study hours by 3 and compute this, okay, and you get 1.15, approximately 1.16 failed subjects. Well, obviously this is just a prediction, and all predictions have errors. If you want to get the confidence interval for this prediction, taking into account the error, you can run again and select here, mark confidence intervals for the predictions. This way you're going to get the confidence interval for the prediction that is going to be between minus 0.17, that is, makes no sense in this case because it's impossible to fail less than 0. So from 0 to the upper limit is 2.49, approximately 2.5. So I can say that if you study 3 hours a day, the expected failed subjects at the end of the course is going to be between 0 and 2.5 with a confidence, with a probability, with a confidence of 95%. The last question is, according to the linear model, is how many hours of study are required at least to pass all the subjects? Well, in this case, again, I want to make a prediction, but in this case, I want to predict the number of hours that I have to study if I want to pass everything. Well, whenever I want to predict a variable, that variable must be considered as the dependent variable in the model. So in this case, I cannot use this model because this model is to predict the failed subjects as a function of the study hours. But if I want to predict the study hours, I have to use the other line. Be careful with this because it's a common mistake. Okay, so we're going to use the other line, and for that, first I need to compute the equation and to save it. Okay, let's go again to teaching, regression, linear regression, and here select as dependent variable study hours, as independent variable failed subjects, and click save model and give a name to the model, for instance regression line study hours on failed subject. And submit. And here we have the equation of the other line that explains the number of hours of study as a function of the failed subjects. As you can see, the coefficient of determination is the same, and we can use now this model in order to predict. And for that, repeat teaching, regression, and predictions. And here all you have to do is select the model that you want to use to predict, in this case the regression line of study hours on failed subjects. And what's the value for failed subjects? Well, if you pretend if you want to pause all the subjects, the number of failed subjects is 0, and you submit, you get this, approximately 3.6 hours you have to study if you want to pass all the subjects. Again, you can get a confidence interval for the prediction. Run again and select here confidence interval for the predictions, and I get the limits for the 95% confidence interval. That is, if you want to pass all the subjects, you have to study between 2.6 approximately and 4.6 hours a day with a 95% of confidence. Okay, that's all for exercise 2. Let's go now to exercise 3, that is another interesting exercise. In this exercise, I want to study how human body metabolize alcohol. We're going to conduct an experiment that consists in drinking a liter of wine, and we're going to measure the alcohol concentration in blood every half an hour. And here you have the data of the experiment. So we're going to load this dataset. Go to workspace, and here I think the name for this dataset in the rkTeaching package is alcohol blood, this one. I'm going to make a copy of this dataset to my workspace, and now I can open this dataset that, as you can see, contains this data that you have in the booklet with two variables, time and alcohol. Okay, the second question is compute the linear correlation coefficient of alcohol and time and interpret it. Well, in order to study the fit of a model, we can use different measures. One of these is the coefficient of determination that we have seen in the previous exercises, but you can also use the square root of the coefficient of determination, that is the linear correlation coefficient. We can get the correlation coefficient in teaching, regression, and correlation. In this menu, in this dialog, all I have to do is select the variables of the study that are alcohol and time, both alcohol and time, and then submits. And here I get the correlation matrix of alcohol and time, and here in this matrix you have the Pearson correlation coefficient, that is the square root of the coefficient of determination in a matrix. So in this matrix, you have the correlation coefficient of the two variables that appears at the rows and the columns. For instance, the correlation coefficient between alcohol and alcohol is 1, because obviously it's the same variable and the correlation is perfect. But the correlation between alcohol and time is minus 2.027. Okay, that's the correlation coefficient between alcohol and time. As you can see, the correlation coefficient is pretty close to 0. It's a little bit weird because you have a look to the data, and according to the common sense, I expected a stronger relation, because the human body metabolizes alcohol with time, so the alcohol concentration is going to decrease with time. In order to see what's wrong with this, what's happening in this exercise, we're going to plot the scatter plot and the regression line on it, because in this case we forgot to plot the scatter plot. And remember that it's a good idea to plot the scatter plot always at the beginning of the regression study. So let's go to part C. I'm going to plot the scatter plot and the regression line. Go to teaching charts, scatter plot, and here select, in this case the dependent variable is going to be the alcohol concentration and the independent variable time. And go to fitted line tab, and here select line linear, because I want to fit a line. then submit, and here we have, well, this is the line and this is the scatter plot. Well, it's obvious that the line doesn't fit well this cloud of points, because there is a clear tendency that is decreasing, is inverse like this, and I expected a line like this more or less, but instead of getting a line in this way, I get this line that obviously doesn't fit well the cloud of points, and that's the reason why I got such a small coefficient, correlation coefficient. Okay, and the reason for this is that I have a point here, okay, that is far away from the rest of the cloud of points. It doesn't follow at all the tendency that you are seeing here, and that's the reason why you get such a bad line, because remember that this point wants to be also close to the line, and we pull the line, and that's why you get this line instead of a line like this. Well, this data obviously is an outlier, and in regression studies outliers are very dangerous because you can get a bad model for a regression study. So let's have a look to the data in order to identify this outlier. This outlier corresponds approximately to 210, and it is the last data in the data set. Okay, it's the last data. As you can see, the alcohol concentration is decreasing with time. In fact, after 3 hours, the alcohol concentration downs to 0.2, but suddenly in the next half hour increases a lot after 2.1. And this is weird because we know that the human body doesn't urinate alcohol spontaneously. So the only explanation is that one of two, or this is a mistake, or this individual has drink in this time, in this period of time. Well, anyway, it's clear that this data is an error. It must not be considered in the study. So we're going to go to the data set, and we're going to remove this data from the study. It's in the last row, so go to the header, right click and delete this row. And now we're going to repeat the scatter plot and the line, run again without the outlier, and we're going to see that now it fits much more better. Okay, if we repeat the computation of the linear correlation coefficient, now we get that the linear correlation coefficient is minus 0.94. That obviously is pretty close to -1, and that means now that the model fits pretty well. It's a good model, to explain the relation between alcohol concentration and time. We can get the equation of this line. Go to teaching, regression, and linear regression. And here, select as dependent variable alcohol as independent variable time. And I'm going to use this model to predict, so I'm not going to save the model, just submit. All I want to know is the equation of the model, and this is the equation of the model that explains the alcohol concentration as a function of time. And as you can see now, the coefficient of determination is pretty close to 1, so that means that the fit is pretty well. It's a good model. The most interesting thing about this line is the slope, that is almost 0.01, and is negative because the alcohol concentration is decreasing with time. But this is the most interesting thing because it explains the speed of alcohol metabolization. Because remember that the slope is how much increases or decreases, in this case, the alcohol concentration with time per every unit of time. So in this case the time is measured in minutes, so I can say that every minute that passes, every minute more, the alcohol concentration is going to decrease almost minus 0.01 milligrams. Sorry, no, grams liters. This is very interesting because it talks about the speed of metabolization. Okay, let's go to part D, the last part of this exercise. And now I want to predict, because since this model fits well, we're going to predict. It says that if, according to the law, the maximum concentration of alcohol in blood to drive is 0.3 grams per liter, how much time must wait this person to drive after drinking a liter of wine? Well, for that, I want to predict the time. I cannot use this model because this model explains alcohol on time, so I have to use the other model. Run again, and here, use as dependent variable time as independent variable alcohol. Okay, remember that always the variable that you want to predict plays the role of the dependent variable in the model. And then save the model, because now I want to predict. Give a name to this model, let's say linear or regression line of time on alcohol, and submit. This is the other line, the equation of the other line. And now we can use this model to predict. Go to teaching, regression, predictions. In this model, just select the model that you want. In this dialog, select the model that you want to predict, use to predict. That is one. And here I want to predict for, according to the exercise, is 0.3. So, and that's all. Submit. And here I get the prediction that is approximately 180 minutes. That is 3 hours. Well, obviously, in this case, if you get the confidence interval for the predictions, you're gonna see that the error in this confidence interval is bigger than in the previous exercise. So the time that you have to wait after drinking a liter of wine for driving is going to be between 108 and 251 minutes with a confidence of 95%. And the reason for such a big error is because in spite of having a high coefficient of determination or linear correlation coefficient, the problem here is that the sample size is pretty small. I have few data in the sample. In order to have a reliable prediction, you need a high coefficient of determination, but also you need a big sample size, because it's not a good idea to predict with such a small sample. Well, finally, let's go to the last exercise of this chapter, exercise 4. It is about the dataset age height of the package RkTeaching contains the age and the height of 30 persons. Okay, first we are going to load the dataset. Go to workspace, and here, and the name is age height. Is this the dataset? We're going to make a copy. I'm going to make a copy to my workspace, and now I'm going to open this dataset. That it contains two variables. The first one is the age of these persons, and the second one is the height. In this study, I want to study if there is a relation between the age and the height. Well, first we're going to compute the regression line of the height on the age, and for that, remember, I have to go to teaching, regression, and linear regression. And here, select as the dependent variable the height, as independent variable the age, and then submit. As you can see here, I get the equation of the model, the height. But if you have a look to the coefficient of determination, the coefficient of determination is pretty low, it's pretty close to 0. So that means that this line doesn't fit well the clouded points. If we have a look to the Scatterplot in part C, go to teaching, charts, and Scatterplot. We're going to represent the H in the y-axis, the H in the x-axis. I get this scatter plot, and if I plot the line, as you can see, this line doesn't fit very well to the cloud of points. That's the reason why I got a coefficient of attenuation very small. So it's not a good idea to use this model in order to predict. And the reason is that if you have a look to the scatter plot, well, it seems that there is a clear tendency, an increasing tendency, a direct relation between the height and the age at early ages when you are young. The reason obviously is because when you are young, your height is increasing with age, but after 18-20 years you stop to grow. Now the tendency changes completely, and from here you have a different tendency. So in this case, if you want to improve your models, it's a good idea to split the sample into groups. And this is known as partial regression, okay? Because when you have two or more clear tendencies in the scatter plot, it's a good idea to split the sample in groups and to fit different models for these groups. We're going to split the sample into groups. One is going to be the group of young people, in this case people younger than 20, and the rest is people older than 20. But for that, in order to split the sample, I need a new variable, a categorical variable, a qualitative variable, with two categories, young and old people. So in order to get that variable that allows us to split the sample into groups, we're going to recode the age. In part it asks for creating this variable age group, recoding the variable. In order to recode the variable, we're going to go to teaching, data, and variable recoding. And here, select the variable that you want to recode, that is the age. And here, remember, you have to write the rules for the categories of the new variable. The rules appears here, from the lowest value in the sample to 20. This is going to be category 1, and from 20 to the highest value in the sample, this is going to be category 2. Okay, remember that you have to write every rule in a different row in this field. And now just give a name to the new variable that is going to be age group. And don't forget this, it's important to select the dataset where you want to put this new variable, and obviously I want to put this variable in the dataset age height. And that's all. Submit, and after this, as you can see here, you get a new variable age group that is a factor, it's a qualitative variable with two levels. I'm going to write the name for these levels. Remember that one was young people and two was old people. And now that we have this variable, it's easy to split the sample into groups according to the categories of this variable. Okay? Now, in order to get in part E the regression line according to these two groups, that is, in order to get two groups, two regression lines, one for young and the other one for old people, all we have to do is we can use this model and run again the dialog in order to compute the equation of the model. And here, in order to split the sample into groups and compute two different lines, one for each group, all you have to do is click here, mark this regression by groups. Okay, and here you have to select as grouping variable the variable that you want to use in order to split the sample in groups. That is going to be obviously age group. With this, we're going to get two regression lines. The first one is for the group of young people, and this is the equation of the line. And the other one is for old people, and this is the equation of the other line. Okay, if you have a look to these two lines, the first one has a slope positive, and the reason is because the relation between the height and the age is direct, is increasing, because as you know, when you are growing, when you are young, you are growing, and as you get older, your height increases, and that's the reason why the slope is positive. While when you stop growing, as you are getting older, now the height stops to increase, and in fact it starts to decrease a little bit, and that's the reason why you get a negative slope in this line. Regarding the goodness of fit of the models, if you have a look to the coefficient of determination for the first line, it's close to 1, so that means that this is a very good fit, it's a good fit. While for all people, the coefficient of determination is 0.36. That obviously is far from 1, so that means that in this case the fit is not good. So that means that there is a strong relation between the height and the age at early ages when you're young, but when you are older than 20, the relation between the height and the age is weak, it's not so strong. We're going to plot now in part F these two lines. For that, all you have to do is you can run again the Scatterplot, and here, in order to plot the two different lines, we're going to select plot by groups, and again select as grouping variable the variable age group. If you submit, you're gonna get two different lines, one for people younger than 20 and the other one for older than 20. And it's obvious, you can see that this line, the red line fits very well, while the blue one doesn't fit so well. Finally, in part G, we're going to use these two models in order to predict. It says according to the linear model, what's expected height for a 14 years old person and for a 38 years old person. Well, obviously in this case, in order to predict, I need to save the models, so I forgot to save the models. I'm going to run again, and now I'm going to click here to save the models, and we're going to give a name to these models. High on age, and submit. And now if you have a look to the workspace, we're going to get two models. As you can see here, the regression line high on age for old people and regression line high on age for young people. Obviously, if you want to predict the height for a 14 years old person, you have to use the model for young people, and for a 38 years old, you have to use the model for old people. Well, let's predict first for 14 years old. For that, go to Teaching, Regression, and Predictions, and select the model for young people. That is this one, and the age is 14. Then submit, and here you get the prediction. So approximately the height of a 14 years old person is going to be 1.53 centimeters. And now, in order to predict for the other person, the 38 years old, all you have to do is change the model, select now the model for all people, and right here the age that you want to use for the prediction, 38. And that's all. Submit. Regarding the reliability of the prediction, obviously this prediction, the prediction for a 14 years old, is going to be this prediction is going to be more reliable than this one, because remember that the coefficient of determination for young people was higher than for young old people. Well, we finished this practice. I encourage you to try the proposed exercise that you have here, and that's all. Bye.